Okay, question 11. A particle is projected vertically upwards from a point P. At the same instance, a second particle that fall from rest vertically at Q. Q is directly above P, and the two particles collide at a position R after T seconds. When the two particles collide, they're travelling with equal speeds. Prove that the distance from P to R equals 3 times the distance from R to Q. So look at my diagram. Particle at P is projected up, so it's got an initial velocity, and its acceleration is minus 9.8. Particle at Q is dropped down. It's got an initial velocity of 0 and an acceleration of plus 9.8. And then they meet somewhere at R, which is labelled there, that's the meeting point. And we're looking to show that the length of PR, so that's the length from the bottom one to the meeting point, is 3 times the length from the meeting point to the point Q. Now, what I would start with here, because it's an algebra question, is writing down all your formula. And if you think about what we're given, there's displacement here, definitely. We want to relate two displacements. So that tells me I need to use my displacement formula, which is S is ut plus a half at squared. But also the last sentence says the two particles collide at R when they're travelling at equal speeds. So that would mean that I need to get formula for their velocities as well. Because the velocity of particle A at the position R will be equal to the velocity of particle B at the position R. And there we go. So we have our formula and they're labelled 1, 2, 3 and 4. Okay. The next thing we need to do is to equate the velocities, because that's what we're told. So that would be formula 2 and formula 3. And that gives me a formula for u. So u works out as 2gt. And then the final thing to do would be to fill that initial velocity into both displacement formulae. So the displacement from P to R would be the distance travelled by particle A in time t. From that we get 3 over 2 gt squared. And then RQ is the displacement travelled by B in the exact same time with initial velocity of 0, and that works out as a half gt squared. As a result, then we can see that one of them is 3 times the other. So if we're to interpret this question, the important things to take out of the text of the question are that the speeds are equal at R, number 1, and number 2, they're projected or let go at the same time. So the time taken for them both to reach R is the same. So you can use the same t in all of your formula. And my interpretation of it then is, I see what we're looking to prove. There's a relationship between two displacements, so I need two formula for displacements. That's the first thing. And because we were told they were equal speeds, we need two formula for velocity as well. And like I said, what you do there is you write down your 4 formula and then apply the conditions that you were given. Velocity is equal, that gives you a u, and then put the u into both displacement formula and see does the question basically fall out. It's not as clear cut as getting an answer immediately, it will fall out as you progress through it. Okay, 2 final questions. This is the first one. You can see there's a lot of text around it, so let's have a look at the text first of all. In it, it says the cyclist just catches the bus. What that means is if he catches the bus, then he and the bus are travelling at the same speed just as he reaches the bus. So the velocity of the cyclist equals the velocity of the bus is a condition that you're going to have to include into your calculations. So you'll have V of A and V of B, 2 formula for those, equate them, and that will give you something. They're also meeting, so that means that the idea behind meeting will also take place. So maybe they have to travel the same distance, maybe they have to travel a distance plus an extra bit. I'll leave you sort that out. Now, just to explain what's going on here with just catching the bus a bit further as well. If the cyclist easily catches the bus, it means that when they meet, he's travelling faster than the bus. If the cyclist can't catch the bus, it means that his velocity is always going to be less than that of the bus. So if the cyclist just catches the bus, it means that he just catches the bus, and if he managed not to touch the bus's velocity from that time on would be larger than his velocity, and the distance would increase. In other words, the minimum distance between them equals 0. That's another way of looking at it. So spend some time on that. Pause the video if you want. We're going to have a look at the next one. This is very much the same. The boy just catches the bus, meaning that when he reaches the bus, his velocity and the bus's velocity are equal. And remember, it is a meeting question, so draw a diagram of how far he has to travel to the meeting point and how far the bus has to travel to the meeting point. Spend a few minutes on that as well. This one is actually easier, I think. And then the following 2 slides are the marking schemes for both of those. So I'll put them up quickly enough, and you can go back to the video and pause the video as necessary to look at them. Marking scheme 1 for the cyclist and the bus. Marking scheme 2 for the boy and the bus.